Hey everyone, get ready to ignite the AI revolution. I'm Praveen and we are exploring Neam, the language for agentic intelligence. Welcome to the future of intelligent systems. Join us as we unleash Neam's power and shape the AI frontier. Subscribe and be part of the spark. In most languages, functions are something you define and call. In Neam, functions are something you compose. You start with named functions, dead simple, move to anonymous functions, flexible and elegant, and then reach higher order functions, where you pass functions, TO functions, chain them with pipes, and build entire data pipelines in single expressions. 3 levels of power. Let's unlock all of them. Functions in Neem use the fun keyword, not Dave, not func, not function, fun, because programming should be parameters are listed in parentheses, the body goes in curly braces, and you use explicit return to send a value back. An important detail, parameters pass by value. When you pass a variable to a function, Neem copies it. The function works with its own copy, so the original is never modified. This prevents an entire class of bugs that plague languages with pass by reference. And notice, no return type annotations needed. The compiler infers the return type from your return statement, less typing, full safety. Need to return multiple values? Use tuples. The divide function returns both the result and a status message as a tuple. On the calling side, destructure it directly into separate variables, result and status. No special syntax, no out parameters, no wrapper objects, just tuples. And recursion works exactly as you'd expect. Here's factorial and Fibonacci, a function calling itself with a smaller input until it hits the base case, clean and direct. Anonymous functions use the fn keyword and have no name. The last expression is automatically returned, no explicit return needed. Store them in variables, pass them as arguments. The arrow syntax with equals dash greater dash than is shorthand for single expression functions. But here's where it gets interesting. The apply function takes a value and the function as its second parameter. We pass double, square or triple and apply calls whichever function we gave it. Functions as data. This is the bridge to higher order programming. Neem has 4 visibility levels for functions. Pub makes a function public, visible to anyone who imports your module. Create limits visibility to your package. Super makes it visible only to the parent module. And the default, no modifier, is private, visible only within the current module. Private by default is a security feature. You explicitly opt in to making functions accessible. This matters enormously when you're building agent systems where you want to control exactly what capabilities are exposed. Higher order functions take other functions as arguments. Map transforms every element, give it a function, it applies that function to each item and returns a new list. Filter keeps only the elements where your function returns true. Fold is the most powerful. It reduces an entire collection to a single value. You give it a starting value and a combining function. Here, we start at 0 and add each number, some 55. Find returns the first element matching your condition wrapped in an option type. We'll cover options in video 8. Sort by lets you sort on any criteria. Here we sort words by their length. And group by categorizes elements by whatever key your function returns. These 6 functions are your core toolkit. Combined with the pipe operator, they replace almost every loop you'd ever write. This is where everything clicks together. We define 3 small functions, Celsius to Fahrenheit, is comfortable and format them. Then we compose them in a pipe chain. Readings flow through conversion, filtering, formatting, and joining. Each function does one thing. The pipe connects them. The result is readable, testable, and maintainable. You can also use inline anonymous functions for one-off operations. And don't forget Neem standard library, std.math for mathematical functions, std.crypto for hashing and encryption, std.time for timestamps, std.io for file operations. These are all ready to use with a simple use statement. Here's our complete program. 3 analysis functions, each built with pipe chains. Word count, split into words, get the length. Average word length, split, map each word to its length, fold to sum, divide. Find long words, splitter, filter by minimum length, lowercase, deduplicate, sort. The analyze function is public. It returns all 3 results as a tuple. In the main block, we destructure the tuple and display each metric. And the final pipeline takes the same text, uppercases it, splits it, filters short words, and joins the result. Every function is small. Every pipeline reads top to bottom. That's idiomatic Neam. Challenge time. Build a mini calculator. Write 4 arithmetic functions. Make sure divide handles 0. Write an anonymous function for averages. Build a pipe chain that computes the sum of squares of even numbers. That's map, filter, and fold in one chain. Write a higher order function that applies any function to a list. And for the bonus, compose 3 or more of your own functions in a single pipe chain. Show me your most elegant composition in the comments. Next video, control flow. But not just if else and for loops. Neam has comprehensions that combine looping, filtering, and transformation into single expressions. 6 loop patterns that will reshape how you think about iteration. We've got the types, we've got the functions. Now we learn to control the flow. See you in video 6.